Okay, so let's unpack this. Think about this for a second. A whole world, right? A planet, but it's not orbiting a star, not like Earth. It's not getting any warmth. It's just floating out there, drifting, a kind of cosmic orphan, wandering through the galaxy, all alone in the dark. That's the really mind-bending idea we're going to get into today.
It really is something profound to consider. These rogue planets, as we call them, they're just incredibly hard to spot. I mean, think about it. No star nearby. They barely give off any light themselves. So they're basically, well, hiding in plain sight across the galaxy.
Absolutely. Hidden. And so our mission for this deep dive is really to understand the pretty amazing techniques scientists are using now, some really cutting edge stuff and sometimes surprising ways to actually find these nomads. We're going to focus on one particular detection, a recent one, that wasn't just about finding one potential planet. It actually sort of proved a whole new way of looking for them, mixing brand new observations with, well, data from quite a while back.
Yeah, that's the really groundbreaking part. It's not just, oh, look, maybe another rogue planet.
Yeah.
This specific discovery, it really hints at just how many of these free-floating worlds might be out there. Potentially a lot more than we thought. It validates this technique that can seriously help us find this, like, hidden population, giving us a whole new census of these wanderers.
Okay, let's get right into it then. You're looking for something that's basically invisible, right? No light. Hidden. How on earth do you even start to look for something like that? Where did this particular breakthrough really kick off?
Right. Well, this is where something called gravitational microlensing comes in. It's pretty incredible, actually. It comes straight out of Einstein's theory of relativity. Basically, if you have a massive object, could be a star, could be a planet, and it passes almost perfectly between us and a distant star way off in the background. Its gravity actually acts like a lens. It bends the light from that background star, focuses it. So for a little while, the background star looks brighter to us, like a natural cosmic magnifying glass just switched on. And that's exactly what happened back in May 2023. I remember reading about this. Ground-based telescopes, part of the OGLE survey, I think.
Yeah.
They saw this brief brightening event, OGLE 2023, BLG 0524. But when you say brief, how brief are we talking? Like a quick flash?
Oh, remarkably brief. This particular lensing event, the brightening, it lasted only about 8 hours.
8 hours?
Yeah, just 8 hours. Think about that. An 8-hour blink of light. But if you interpret it correctly, it could be pointing to an entire hidden planet.
Wow, 8 hours.
Yeah.
That's such a tiny window to catch something potentially that huge. I mean, how hard is it to be sure about something that happened so fast? Did the team, have doubts initially? Because it's so short.
It's a huge challenge, definitely. Catching the event itself is one thing. Using surveys like OGLE, but confirming it, especially from just 8 hours of data, that's tough. And this is where the surprising look into the past comes in. It turned out the key confirmation wasn't really in more brand new data right away. It was actually hidden away in digital archives, decades-old observations. Okay, wait, so the answer wasn't new observations, it was old ones from the Hubble Space Telescope archives. You're saying Hubble had already looked at that exact same patch of sky way back in 1997 for something totally different?
Exactly. Part of some unrelated microlensing follow-up back then.
So that gives you, what, like a 25-year baseline of observations for this one spot in the sky? That sounds amazing for microlensing. So what did looking back at that old 1997 data actually show them compared to the 2023 flash?
Well, the team, led by Matthias Kapusta, they went back and looked very, very carefully at those old Hubble images from 97. What they were hunting for was any sign of a star, like a host star, right near where that 2023 brightening event happened. And the crucial thing they found was nothing. At least nothing brighter than a specific limit, what astronomers call magnitude 21.7.
Magnitude 21.7. Okay, for those of us listening, what does that actually mean? How faint is that? And why is not seeing something that faint so important here?
Right. So magnitude 21.7 is incredibly faint. You'd never see it with your naked eye, not even close. It's really pushing what even Hubble could reliably detect back in 97 with those particular exposures. And the fact that they didn't see anything brighter than that, right, where you'd expect to see a host star if this were a normal planet orbiting one, well, that really strengthens the case that this object, the one causing the lensing, might actually be floating free, a rogue. It suggests maybe it got kicked out of its original solar system somehow, gravitational interactions maybe, or maybe the star it orbited died dramatically.
Okay, so this is bigger than just finding one potential rogue planet. It's like proof of concept for a method. Finding this orphan world this way, it hints that maybe the early days of solar systems forming were, I don't know, a lot more chaotic or violent than we used to picture.
Precisely. That's exactly the implication. It suggests that planets getting ejected might actually be a pretty common thing. Maybe they get slingshotted out during formation, especially if they form in crowded star clusters. Or maybe later on when their star goes through its, final phases. So this one detection, confirmed this way, it's strong evidence that our galaxy could actually be, well, teeming with these castaway worlds. And that really changes how we think about planetary systems forming and how stable they are.
That is really fascinating. So, okay, this object is just drifting out there alone. What about its size? Can they figure that out from just, an 8-hour blip and some old photos?
They can get an estimate, yeah. It's actually a
What?
pretty good estimate, considering it depends a bit on where they think the object is located,
Right.
whether it's in the main disk of our galaxy, which is, relatively less crowded, or in the really dense central bulge.
Yeah.
But based on the lensing signal, the mass estimate falls somewhere between roughly the mass of Earth and the mass of Saturn.
Earth to Saturn. Okay, that's still a pretty big range, but yeah, incredibly specific for something you can't even see directly. So, what are the catches? Are there limitations? Could there still be like a really faint star hiding there that Hubble just missed back in 97?
That's a really important point. And yes, that's the caveat, scientific honesty, right? Even though Hubble is amazing, those specific 1997 images were what we call shallow exposures. They weren't super deep looks. So while magnitude 21.7 is very faint, it's still possible. There's a chance a really dim star like a red dwarf, or maybe even a brown dwarf, a failed star, could be there, lurking just below that detection limit. So the rogue planet idea is a strong hypothesis, probably the best fit, but we can't say with 100% certainty just yet for this object.
Right. Okay, so it's a huge step, confirming the method works, but this one detection really just opens the door, doesn't it? Proving you can combine the old and new data like this. It really highlights what we need next, I guess. So what's coming up? What's on the horizon for astronomers trying to hunt down more of these elusive worlds?
Yeah, this breakthrough really underscores the need for even more powerful tools, more sensitive instruments. We've got the James Webb Space Telescope, JWST. Its infrared capabilities are just incredible. It might be able to peer into these regions and look for even fainter potential host stars, pushing that detection limit way down. And then the big one for this field is the Nancy Grace Roman Space Telescope. It's planned for launch around 2027. Roman is actually being designed specifically with a massive microlensing survey in mind. It's expected to find potentially thousands of rogue planets.
Thousands. Wow. Okay, that really could rewrite the galactic census, couldn't it? So this deep dive, it feels like we've just, scratched the surface of this huge galactic mystery. It leaves you wondering, doesn't it, how many of these orphan worlds are really out there, just roaming the galaxy, hidden from our usual ways of looking? And what does it tell us about how planets even form if so many get kicked out?
Exactly. And, with Webb already up there and Roman coming online, it really pushes the question, can we really ramp up these discoveries by keep doing this, by cleverly integrating the real-time alerts with all this amazing archival data we've built up over decades? Like they did here, that method seems incredibly powerful.
It feels like the quest to actually map these nomadic planets, it's really only just getting started. And it could totally redefine our picture of the galaxy, showing us a universe that's maybe far more active, more dynamic, maybe even more chaotic than we ever really imagined.